In this video, we'll be giving you an overview of the Fundamental Theorem of Algebra, then explaining the generalized equation for it, and then finally talking you through the methodology with which you can go from A to B. To get the most out of this video, it's best if you know the basic concepts of complex numbers, polynomials, and how to graph on the GDC. Here are some reference questions for each concept, so if you find yourself confused with any of them, it's best if you learn these concepts in depth first through the other explainer videos on this channel. As a theorem, imagine you're the owner of a juice shop that's famous for giving customers exactly the flavor they want. You can give them the perfect amount of sweetness, sourness, texture, you name it. No one knows how you do it, but it's really not sorcery. When your customers request a flavor, you're able to break it down into the exact fruits that will make it. Nothing fancy, just the right combination of the basic ingredients. Just like making the perfect juice, the Fundamental Theorem of Algebra is all about breaking complex equations down into its simplest parts. Developed through the collective effort of multiple mathematicians in the 18th and 19th century, the theorem tells us that any polynomial of degree n has n roots. So, an equation like this, where the highest degree of x is 4, would give 4 roots. Similarly, 10x to the power of 5 would give 5 roots as well, because if you imagine the descending degrees of x with a coefficient of 0, it will still fit the standard form of polynomial. The idea that a polynomial can be broken down into its roots can be expressed through this generalized equation, where the left-hand side is the standardized form of a polynomial, where the variables of a represent the coefficients, hence an cannot be 0, while the remaining coefficients can be 0. On the right-hand side, we have a factorized form of the same equation, where w is the root, also known as a 0, of the equation. W is not limited to real numbers only. It can also be a complex number, so expressed in the form of a plus bi. Just like how, as a juice owner, you were trained to break unique juices down into their basic components, you can also learn to convert polynomials to their roots through various methods.
Now that you know that a polynomial can have both real and imaginary roots, we need to find out whether a polynomial has imaginary roots or not. And to find out that, we need to use the discriminant of the quadratic formula. And when you plug the numbers in for the discriminant, if the number is negative, it means that it has imaginary roots. So for example, in this quadratic 2x squared plus 3x plus 5, a equals to 2, 3 equals to b, c equals to 5. So if you plug it into the discriminant, which is this, b squared minus 4ac, it is 3 squared minus 4, 2 times 2 times 5, which is equal to 2 minus 40, which results in negative 31. And this is a negative number, so it has imaginary roots because it is negative. So next, we need to know how to factorize these polynomials knowing that it has imaginary roots, because if it's a real, you can factorize it using difference of 2 squares, or just factorize it by putting into brackets. But because quadratics with complex number roots cannot be factorized normally, we need to use the quadratic formula, which is this. So same thing, a equals to 2, b equals to 3, c equals to 3. Plugging these to the quadratic formula, negative 3 plus minus root 3 squared minus 4, 2 times 5, 2 times 2 equals to negative 3. Just found out that it's negative 31, so it's negative 31 divided by 4. So you can see there's a plus minus sign, means that the first imaginary root can be negative 3 plus minus negative 31, can be plus. And if you alternate this sign to negative, you can get the second root, which is negative 3 minus root negative 31 divided by 4. These are 2 roots, and this leads to conjugate pairs, where interchanging the imaginary part of the root gives you 2 roots. So if a plus bi is root, a minus bi is a root, And if 3 plus 2i is a root and 3 minus 2i would also be a root. So it will be very convenient when you want to like factorize a polynomial. You can just like multiply these two together and this will give you a real number. So since imaginary roots always come in pairs, so if the number of roots is odd, like 1, 3, or 5, there would be at least one root, because if there's 3 roots, there can only be the maximum of 2 imaginary roots, and the remaining one is gotta be real. And then for 5, it can be 2 conjugate pairs or just 1, but there would also always be at least 1 real, because it's odd. Okay, so next,
now to calculate the factors of polynomial, you first need to find the first root using the factor theorem. And the factor theorem states that if f(x) equals 0, then x is a root. So for example, in the polynomial x cubed minus 2x squared plus 4x minus 8, we need to first test the factors. So there's a trick where you need to test the factors of the constant, which in this case is 8. So you should test 1, -1, then 2, -2. So I will first try,
which means that I need to sub 1 into all the x's in the function.
So 1 plus 4. So this will give you plus 4 minus 8. This is not equals to 0, so 1 is not a factor. Next, you need to test -1. 1/3 minus 2 plus 4. This will give you -1, -2, -4, and 8, which is also not equal to 0, so it is also not a factor. Now, testing f2, subbing 2 into x gives you this. 8 minus 8, this can be cancelled, and this is also can be cancelled. This equals to 0, which means that 2 is a root. 2 is a root. And then when you write this into a linear form, it is x minus 2 and then some polynomial that is in the power of 2. So the next step is to find this using long division or synthetic division. So in long division, and you just need to copy down the polynomial. So then write down the linear factor of the root that you just found, and then just put x squared here, because when you multiply this it gives you x cubed minus 2x squared, and when you minus this you get 0, and then you just copy this from down, and then you do plus 4, because when you multiply it's minus 4x minus 8, and plus 8 means this is 0, so this will be x squared plus 4, like this. But now you can also get the same result using synthetic division. Means that in the polynomial you need to write down the coefficients of each like x's. 1, -2, 4, -8. Then write down the root, which is 2. Drag this down to 0. You add this 1, multiply 2, plus 0, multiply 0, add 4, multiply up there, right here, 0. This means that it is x squared plus 0x plus 4 this gives you the same result as above. So now, the last step, we copy this. Then we find a complex root using the quadratic formula. So when you check whether this is it contains complex roots or not. So to check, as I've said, you need to use the discriminant b squared minus 4ac, and in this essentially is written as this, so b squared minus 4ac, this gives you negative 16, so it's a negative number, so has complex roots. So, and then now that we have proven that it has complex roots, we cannot use the regular method of just factorizing it into real roots of linear factors. We'll have to use a quadratic formula to find out the roots of this quadratic. Okay, so the quadratic formula is negative b squared minus 4ac 2a equals to negative 16. 2a gives you times 16. 2 just gives you 4i. 2, this is plus minus 2i. So it means that since for quadratic formulas, this is plus and minus, because when you root a number, it can either be positive or negative. This relates to what I've said about conjugate roots. So if you write this into the fully factorized form into linear factors, it should be x minus 2 times x plus 2i and x minus 2i. Now, to check your understanding, please pause the video and do this following polynomial using what you've learned in the video just now. Okay, so first step, use the factor theorem to find first root. So since this 13, I'll first test 1, negative 1, 2, but as you can see, so I'll test 1 first. F1, this is it's cube minus 5 squared minus 11, 1, 13, 1 minus 5 plus 17 is 13, 4 plus 4 plus 4. This equals to 0, so 1 is a factor. You write it on a linear form as x minus 1. So I will use synthetic division because it's quicker. So I need to find simplified version, quadratic with the factor, and it is 1, negative 5, 17, 13, the root is 1. 1 times 1. Do you add? It's negative 4, multiply, put here negative 4, 13, multiply, put it here, 0. So this will be x squared minus 4x plus 13 times the factor we just found here. So to check if this is contain complex roots, a equals to 1, b equals to negative 4, c equals 13, b squared minus 4ac, 16 minus 52 gives you 3, negative 36. which means that it has complex roots. Okay, going up here, to find a complex root using quadratic formula. So negative b squared minus 4ac negative b minus 36 divided by 2 a says 36 2 plus minus 6i 2 plus minus 3i is one of the roots. It's the root, and then as I said, conjugate pairs. So the final answer would be x minus 1 times x plus 2 plus minus 3i and x plus 2 minus 3i. Hope you got this answer. Thank you.